Okay, hello everyone. So I'm back today again with now variable size sliding window. But this variable size sliding window could be simple. Okay, it wouldn't be very hard level. I'll be covering in the next few videos the variations of variable size sliding window also. Okay, so there are so many variations of the variable size sliding window which I've already covered in my previous first video of this playlist of what all topics I'll be going to cover. So all those topics except the first fixed size will come under variable size only. Ready? Okay, so here what is the major thing? So you are not provided with k size of sliding window, fixed size of sliding window. You're not given that k, that okay, in this much size only you have to find it. But again, it is subarray or substring related problems only. Okay, no change in that. Repetition should be there, but mainly the ask would be to find maximum length or minimum length of subarray satisfying some conditions. Satisfying some conditions. Okay, so now that's what we have learned for maximum length or minimum length in prefix sum subarray also. But there the condition would be on addition of subarray, which I have mentioned yesterday also in yesterday's video also. Okay, so I'm again mentioning it. If the condition is related to sum of subarray, uh, which sum should be something k or all, then prefix sum method will be used using map. Okay, otherwise you can use this sliding window method, and you will clearly find the notice between these two things. You will clearly observe the difference between them. Now there are two types of variable size sliding window. First is to find the maximum length of sliding window. So I'll be going to teach you two different templates. One is to find the maximum length of subarray or substring. Okay, and the second one is the minimum length. So first let's go with the maximum length. So the question could be simple, that find maximum length of substring or subarray satisfying some given condition. Okay, satisfying some condition. So what you have to do, you have to decide three factors on both of this. Okay, you have to decide three factors. First is the calculation part. Okay, first is the calculation part. Second is what, there could be two things over here. If condition satisfies k. If you remember in fixed size what we are doing, our first if is if the window size is less than k, then we are just doing j plus plus, and if the window size is equal to k, then we are calculating the answer and sliding our window, and the original calculation we are doing on top only while entering into the loop itself. Here what happens, we will done the calculation part and the loop itself while we enter. Now if the condition satisfies k, so there is some condition, or condition k satisfies, sorry, if condition k satisfies, then what we will do, calculate answer, and we will do j plus plus. This is for the maximum length of subarray. Okay, there is slight difference in maximum and minimum, so this we have to do for the maximum. And then in else if part, what we will do, we will do the while loop until I less than equal to j, and condition not satisfying k. Okay, and condition not satisfying k, so there we will just do the sliding of window. Then we will do the sliding of window, and of course I plus plus j plus plus would be there in this case. In this case, okay, so this is for the maximum length of subarray. Maximum length of subarray. So it will be better understandable if I go to the question and we will solve one question of maximum and one question of minimum. Clear? So our template will look like, we will have int I0, J0. Okay, maximum answer also 0, maximum length which is initially 0. So simply, as we are doing in the fixed size, we'll do the calculation part. Now this calculation could be anything, storing in the map the frequency if it is substring related questions. Okay, or store or calculating the sum, or calculating something, calculating the count, doing the count. Okay, so if condition satisfies, let's say I have given that some condition such that, let's say if I write, for example, condition is unique characters in substring should remain 2. So my condition is our unique characters should remain 2. So our calculation would be map of s of j plus plus every time. Okay, and what should be my condition satisfies? So my condition satisfies would be map of, if map of, if map dot size should remain 2, or at least 2, or at most 2, or something like that. So let's say here exactly 2. So if map dot size is equal to 2, so this means my condition is satisfying. My condition is satisfying. So what I'll do answer is equal to maximum of answer comma, I have to always maximize the substring or subarray length. Mostly the question will be like that only. So we'll maximize the length. Length is j minus I plus 1, window length. Okay, and we will do j plus plus. So this is our first part. Now our else if part. Now our else part. Sorry, else part here. Now our else part, wherein we will run the while loop. Now what happens? Now you have to decide. Now you have to decide always what happens. Equal to k condition, you will put it over here. Now you have to decide in this while loop. Okay, condition not satisfying k, it should be either condition less than k or condition greater than k. These two cases could be possible. So that you have to think depending on the question. So now this question says that our condition is unique character in substring should remain 2 only. Okay, whatever substring we will choose, we have to find maximum length of such substring such that the unique characters remains 2. So we have done it. Okay, so until j we have done. Now what could happen? What could happen? Our unique characters could not remain 2 until I to j. So what we have to do, it could be either greater than 2, it could be either greater than 2. So as and when we start removing from the I, we have to check. Until it is greater than 2, we have to remove. Until it is less than 2, we do not have to remove. Okay, sliding window means to remove some parts starting from the ith index. That is what our sliding window means. So here it says that it should be equal to 2. So until what part we have to remove? So if we have come in the else, so if the condition is not satisfied, then what could be that other condition? So that other condition could be that map dot size has been greater than 2. Then we have to start removing from the ith part. So we have to do this until I less than equal to j. And let's say, so here the condition is greater than k and map dot size greater than 2. Then we will slide window. So what do I mean by sliding window? So we have to try removing the part of s of I from the map. And if at all it became 0, then we will erase it fully from the map so that it does not count. Okay, so that it does not count, and we will do I plus plus under this while loop. Okay, and every time we will do j plus plus. It's always better to again do the calculation at the end of the while loop. It's always better. It will be considered in this if loop, but sometimes it won't be considered. So it's always better that when we move out of the while loop, that means now our map dot size has become equal to 2. So we'll just check if map dot size is equal to 2 at this point. We will just calculate our answer is equal to maximum of answer comma j minus I plus 1. Anyways, we have to do j plus plus in this else part also and this if part also. Both of these things done. So this answer is our maximum length. Clear? I hope you got this. So let's just quickly move to one of the question of maximum length, and then we will move to the how to calculate for the minimum. Fine. The question says that a teacher is writing a test with n true false question where t is true, f is false. And now he wants to maximize the number of consecutive questions with same answer. That means continuous t in the answer or continuous ffffs in the answer. Okay. So these are the original answer key. The answer key is the original answer key. In that answer key, he can replace the question and make it true or false. So he can make some t's to f's or some f's to t's. So how many? At most k changes he can do. Okay, so here k is 1, so at most one change he can do. He can change either 1f to t or 1t to f maximum at most. Okay, that he can do. So we have to find how many maximum number of consecutive t's or f's remains in the answer. Now, why did I choose this question? We have done the same question in the fixed size sliding window in the previous video. Okay, wherein we have to make ones together or zeros together by doing the number of swappings. Okay, so there we did fixed size sliding window, but there is not a condition of this k, like okay we have to do at most k swaps only. There it's written that we can do any number of swaps and we have to make all these ones together and zeros together, and that is swaps, not changing. Here it is not swaps. Here it is changing, and that too at most, not exactly. If it is exact also, then it's also true. Then it's also okay. That okay, by doing exactly 1k, if I am doing, then okay, whatever is the total t, I can make one size bigger of it and I can check that how much is possible. That way I can make the fixed size k of sliding window. But here it is again at most k. So at most k times only you can change, maximum k times. So it could be possible that we can get our answer of maximum consecutive t's by changing it less than k times. Okay, that could be possible, but that by changing 0 times also we could get maximum answer over here. It's not possible in this case, but I'm just telling one of the test case. So that's why we cannot use fixed size sliding window over here. Okay, so that what could be the case here? So let's say this is what you have given. Okay, I can change this f, or I can change this f to t. If at all I'm planning to make t, I can only change one. So if I make this, then 1, 2, 3, 4, 5. If I can make this, then also 1, 2, 3, 4, 5. So 5 is the answer. That's what I'm getting. So I got that 5 is the answer, is what I'm getting. We have know that we have to make it the maximum number of consecutive. So again, it's the maximum number of consecutive t's or f's together. So that means we have to return the maximum length of such subarray where it is all t's or either all f's. So that's what we have learned yesterday. Either we can do all t's together or all f's together. So here we have to make the function of sliding window. Okay, wherein we can try to make all t's together or all f's together. One of those two, and whatever is the maximum we will return. Clear? Now, what could be the approach over here? The same thing what we have learned. So int I0, J0. What can we do is, while j less than n. Let's say I'm doing this for t, or I'm doing this for character c. C is either t or f. So I have to check how many times I need to change. So what I can do? So if my s of j is not equal to c, and that means I have to change it. So I'll do count plus plus. That means I have to change it. Now, what is our condition? Our calculation is that should be at most k times. So, our this thing, first part, if condition satisfies, so our condition satisfies is this should be at most k. So, it should be less than or equal to k. It should not be greater than k, at most k. Then I can calculate my answer. So, my answer would be nothing but maximum of answer j minus I plus 1, and I'll simply do j plus plus. And what could be my, so if at all this at most or at least kind of question condition came, you would easily know that here count less than equal to k came. So of course in the while it would be greater than k, but whenever it is exactly equal to like condition which I've explained in this maps example, then you have to think of it. Okay, so now what could be the condition? So while I less than equal to j and our count is greater than k, until that point we have to remove from the ith part. So for removing, what we will do? Again, if S of I is not equal to C, that means we have taken it into the consideration. We have taken it into the count, just like previous question yesterday we have done. We'll do count minus minus. Okay. And we will do I plus plus every time. Again, after coming out, we can check if count is less than equal to K. It's no ways bad to calculate this again. Answer comma J minus I plus 1. And we will always do J plus plus in else part also. Sorry. Okay, we'll return it. So let's just quickly code it. Okay, so we can make one sliding window function over here. We'll pass this answer key string So I'll passing it as ampersand s, this k, and this character c, I and j to be 0, and our answer also to be 0. We'll check if s of j is not equal to our this character, then we will do count plus plus. We will have one count also here and how many changes we are doing. Okay. Now if our condition satisfies, so if count is less than equal to k, what are we doing? We're calculating our answer. So we'll calculate our answer and we will do j plus plus for sure. And now in else, if the condition does not satisfy, so if it is over exceeding or it is under, so here it could be over only. So while I less than equal to j and our count became greater than k, we have to remove. So if s of I is not equal to ca, then we will do count minus minus, and every time we have to do I plus plus. After coming out of the while loop, it's always better to check that if count is less than equal to k, clear, we will return this answer. Now what we have to do, so in 10 is equal to, oh no need of this, we can just to do for true case, so int I am making it as true case. Okay, so this sliding window wherein I am passing this answer key k and t as the character, and false case, so here it could be sliding window answer key f case. Okay, we have to return maximum of, either we can make all trues or all f's or some f's. Okay, so here our n would be s dot size. Let's just try to run and submit it. Clear? Let's quickly go for the minimum part where we have to do for the minimizing. Okay, so for minimizing the subarray or substring length, what could the three steps we have to do? First is same, do the calculation part. Do the calculation part. Now second thing, what we have done for the maximizing, we are firstly checking if condition k satisfies or not. So here we have to check if condition is not yet satisfying, means we are under condition, means we are under condition. So let's say if sum should be equal to k or something, then until now the sum is less than k, or the maps frequency should be 3 or 4, but until now it's less than 3 or less than 4. So it is under condition. So if condition is not satisfied, so we are under condition, then we will simply do j plus plus, just like we are doing for the fixed size. We are checking the window length less than k, then we are doing j plus plus. So here we are checking condition not yet satisfying, so it will satisfy in the future. Okay, you have to predict that what could be here, it could be either greater than k or it could be less than k also. Both of this could be possible, that you need to define on basis of your question. The same which I have told you in the while loop, while we are doing for the maximizing, that you have to define whether less than or greater than, which is not satisfying k. But here it could be mostly lesser than k because it should be under condition. So it will satisfy in the future. Okay. In future means we have to do j plus plus. I have no option. So it could be condition less than k or condition greater than k. And now the third step in else part. So in else part, what I have to do? Now once condition is satisfied, until now condition is not satisfying. Okay, so in else what it comes, condition started satisfying. Just mark my words, I'm saying condition had started satisfying, so we will start calculating the answer. So we will start calculating the answer, and we will try to remove from I letter or number. So now we have the subarray or substring is from I to j. So now our condition started satisfying. It's satisfied for I to j now at one point. So we have came under else part. We'll calculate the answer. What we can do, we can try to remove from the I part and see that after removing from the I part, does my condition still satisfying? Then that could be the minimum answer, right? Anyways, I have to find the minimum length. So we'll start calculating the answer and we'll try to remove from I letter or number, whatever it could be, character or number. If it still satisfies, we will update the answer. So what we have to do here, while I less than equal to j and condition satisfying k, so condition remains satisfied, we will calculate our answer. So here our answer could be mainly what? Minimizing j minus I plus 1, and we will slide the window, of course. So we will do I plus plus, and in else part we will do j plus plus. So after removing, so now here we cannot do anything after removing outside, because we have done whatever we have to do under the while part. So we do not have to calculate the answer after coming out of the while loop. Okay, you got the difference between both. For maximizing, you have to do if condition satisfy, calculate the answer. And now under the while loop, what you have to do, until condition is not satisfying, removing from I, all these things. Here what I have to do, here we have to, until condition is not satisfying, we will do j plus plus, j plus plus. We'll move ahead, move ahead. Once it starts satisfying, now we will starts calculating our answer, and we will sliding the window. Again, it has stopped satisfying. We will go again in this if condition not satisfying, and then we will do j plus plus. But once it has satisfied for I to j, we will check for I plus 1 to j also. We'll check for I plus 2 to j also, that whether it is satisfying or not. Okay. So let's say this is our question. Here given an integer array cards where cards of I represent the value of the ith card. A pair of cards are matching if the cards have the same value. Okay. And we have to return the minimum number of consecutive cards we need to pick up so that we can have one matching pair. A pair of matching cards among the pick cards. So we have one matching pair. So what I can do is, if I tell you the brute force, okay, at one point I should get map of something number equal to 2. That means map of 1 equal to 2 means I've got one number two times, so I've got one pair of matching card. That's okay, I've got my answer. Or I should get map of 2 is equal to 2, or 3 is equal to 2, or 4 is equal to 2. My condition is saying I should get at least I should get one matching pair. I should get one matching pair, and I have to pick up such minimum number of cards so that I can get at least one matching pair. Fine. So with this simple, what we can do, while j less than n, okay, what we can do, we will start for the calculation. So our calculation will be, we will always do map of cards of j plus plus, map of cards of j plus plus. So now if after doing this, if it is not equal to 2, so it remained less than 2 only, then of course I need to move ahead. Okay. But once I got it, so I came into the else part, and now I'll check until I less than equal to j and map of cards j remain 2, until that part, until it is remaining 2. So that is what my satisfying condition. I can calculate the minimum answer over here, and now I can slide window. So for sliding window, I can remove I and check again. Is it still satisfying? So I'll do I plus plus, and we can do j plus plus over here. So this is how my answer came. So let's just do brute force for this. So you are at I and j at 0. Okay. So you are at here, and we can have one answer also. For minimizing, always keep answer as n plus 1, because maximum length could be n plus 1. Maximum could be n, so we'll take 1 plus. So it's return. If it is impossible, then we'll return minus 1. So after doing all this stuff, if we have got our answer as n plus 1 only, it's not yet updated. That means I didn't get any matching pair, so I'll return minus 1. Otherwise, I'll return answer. So now we will check. 4, map of 4 is 1. It's less than 2. We'll do j plus plus. We have came to 3. Map of 3, 1. Again, we will do. Map of 5, 1. Again, it will be 2. Now map of 3 has become 2 and we will check. Is map of 3 lesser than 2? No, it's greater than equal to 2. So it's equal to 2. So we have came to this condition. So while I less than equal to j, I is at 0, j is at 0, 1, 2, 3, third index. And map of cards j means map of 3 is 2. We'll calculate the minimum answer. So here my answer will be first time will be what? 3 minus 0 plus 1, 4 length, which is true. This 4 numbers. Okay. And I'll do the map of cards of I minus minus. Now I'll try to remove this 4. So I'll do map of 4 minus minus. So it has become 0. So we need to check if map of cards I is 0 after removing, erase it from the map so that it won't comes under the counting part. So we'll erase it. So map of 4 has become 0 now. So we'll erase it and we will do I plus plus. So now my I is at this 3 and my j is at this 3. So I is at 1 index, j is at 3 index. Again map of cards of j, which is again 3. Cards of j is what? 3. J we haven't increased. We just increased I. So map of 3 is again 2. So after removing one this thing, this 4, again if I take this 3 options, then also I can get one matching pair, which is 3, 5, 3. I can get a pair of 3, which is matching. So I can calculate, update my answer to be 3 minus 1 plus 1, which is what? 3. So now my length is updated to 3. And now I'll remove 3. So if I remove 3, map of 3 has become 1 now. Okay. And now when I'm at this 3, map of 3 is 2. No, it became 1. So we'll come out of this loop. We'll do j plus plus. So now our j will be at 2 over here. So again, we will do map of 2 plus plus, map of 2 less than 2. No, no possible answer. No possible answer for this 3. 3 we have already removed. So we have checked for this thing and we have removed 3. Now no need of 3, right? For 3 we have already checked. So this no answer available. Again for 1 also no answer available. So our answer is 3. Minimum length of consecutive cards we have to take is 3, 5, 3 so that we can get one matching pair. I'll give you the question link in the description. You can solve. So we have covered simple variable size sliding window. In the description, you will get the similar type of questions. Either could be of minimum length or maximum length. And I'll give you the handwritten notes. So our next session would be on little bit harder level of sliding window variable size. Same topics. I'll try to do some lead code hard level of questions or medium to hard level of questions. Okay. In next video, mostly I'll be covering sprinkler asked sliding window variable size question. Okay, stay tuned for the next video. Do like, share, and subscribe. Bye bye.